Welcome back. We are on lecture series 4 and it is a long one, but it's still simple to understand, simple to follow. Hopefully my explanations are going to be just a sort of a reminder as to what the commands meant to achieve. So far, we have been talking about data definition languages where we would be describing ways for extracting data from SQL. So the data is there. We are not doing anything. We are not manipulating the data. We just want to see it. It's kind of a one-way command, meaning the data is there. Let me take a peek and take a look at the data and see what it is. I want to see and extract information from the existing database or a spreadsheet. But the data manipulation language allows me to insert, to delete, and modify the data. So that's different. Data manipulation language, DML, is coming. We have insert, we have update, we have delete. We spoke of update in the past many times. Update is simply says if I have changed one of the smaller tables due to the 3NF, 4NF, whatever it is, I should be able to just simply update. And if I wanted to get back to my original table, all of the information is supposed to be first consistent. The integrity criteria has been met. The data is consistent, and then it's going to give me updated version of the data. We have spoken of that in the past, but we are going to see what this command basically does in a moment. Insert and delete. So let's say slowly go by that. Delete from the table where the condition is met. And then semicolon. Remember in one of the earlier slides on this lecture 4, we spoke of the semicolon and where the semicolon is going to be. So delete from table where the condition is met. And if I say, so this is going to be selected records that are going to be deleted. And selected record needs to be meeting the condition. But there is, if I put the semicolon here, if I say delete from the table and then semicolon, it means I want you to delete everything from the record, everything on that table, except the table itself, which would be the label of the columns and so on, okay? Requesting to delete tuples from a table is similar to the way we were querying data. We can delete only the whole of the tuples. We cannot delete values on only particular attributes, much the same as select, just that in this case, the selected records will be deleted. If the where clause omitted, all table records will be deleted. We have spoken of that before. Delete from the student table where the department name is computer science. You can see computer science now has been removed. This is the computer science that has been purged from the table. I like this style of code box, and the reason is I know what the command functionality is supposed to be. I know where the which table I'm looking at. I know what the condition is going to be. I like this type of a command. Some people are used to write everything in one line. That is also too doable, but I feel very comfortable doing it this way. So basically, delete command operates on only one relation. If you want to delete tuples from several relations, you must use one delete command for each relation, for each table. Relation means table. Where clause may be as complex as a select command. Where clause is, so you could potentially have many conditions, logical operations. You can have anything you like, similar to select. Delete from a student is going to delete all of the records from the table because your semicolon is here. That's why. You don't have where anymore. The where is not there. Delete from a student where the GPA is less than, select the average from the student department name, computer science. So what happens is that I'm going to have department name, computer science. I'm going to get the average of the computer science, and then I'm going to see any student where the GPA is less than the computer science GPA, then I'm going to report that back to you. So if you take a look at that, 2.6, 2.9 are purged because in the computer science department, I have, if you take a look at my table, I have 2.6, I have 2.9, I have 3.2, 3.6, and 3.3. And if I remember correctly, the average was 3.12, 3.12. So anything that is below 3.12, I'm going to exclude it. So it's going to be, Beck is going to be removed, Mitchell is going to be removed, but the rest of the computer science is going to be still there. This is in relationship to computer science only, because where the where command is only applicable to the computer science, okay? You could also, I would like to have actually a slight modification of what just I explained. This says from the student, any student whose GPA is going to be less than the computer science GPA. So the fact that I removed Beck from this table is not because this person is in computer science. No. The fact that I removed Mitchell is not because this person is in computer science. No. The reason I removed them is because 2.6 and 2.9 is less than 3.1. I believe 3.1 was the average. So if you take a look at that, 3.2, 3.8, all of that is going to be there simply because they are above 3.1 or equal to 3.1. I'm just saying less than. I didn't say less than or equal. I said less than. So in this case, the reason these two individuals have been purged is simply because their GPA is less than the computer science GPA, and it's going to be purged from the student table. So if I had Alan, and Alan was 2.9, I would have removed it, even though it is in mathematics, because 2.9 is less than 3.1 for computer science, okay? Insert is to insert into a relation. We either specify a tuple to be inserted or write a query whose result is a set of tuples to be inserted. Insert into, so this is capital, as you can see. Into the table name, I have table name. I have column 1, column 2, up to column 3, but I do need to have the values, corresponding values. So if I have column 1, value 1, column 2, value 2, column 3, value 3, I need to actually match it up. So let's take a look at this. Insert into department the name and the chair and the budget. So I'm going to do that. It's going to be, the name is going to be the law department. The chair is going to be Brian, and the budget is going to be 43,000. And that's what happened. I just added one row into my department table. You can copy all columns from one table to another. So insert into table 2, select everything asterisk from table 1 where condition is met. Copy only some columns from one table on another one. Actually, as you can see, again, condition is going to kick in and apply. Insert into lecturer. Select ID, name, department from a student where the department name is equal to computer science and the GPA is greater than 3.5. I didn't say greater than or equal. I said greater than 3.5. I didn't print the table, but I think the instruction is quite clear. I would encourage you to type it into your Jupyter notebook or whatever platform you're using, and then see what you get as a table outside. In certain situations, we may wish to change a value in a tuple without changing all values in the tuple. So update table name, set column 1 to value 1, set column 2 to value 2, where the condition is met. I hope I have an example. Let's see if I have an example. Let's take a look. Yep, this is a good one. Update department, set the budget as equal to budget times 1.1. So this is going to be the old budget line times 1.1. That's going to be the new budget line because of inflation rate, because the university is doing great, because the organization is doing great, and they have raised the budget by 1.1, 10%, everybody, okay? So I'm going to update that. Update department, set the budget as equal to budget times 1.1, where the budget is less than 30,000. What does that mean? Only those budgets that are less than $30,000 are going to be upgraded by 10%. So that's going to be the change. and this is going to be the output. So 48,000 doesn't change, 57,000 doesn't change, but 24,000 is going to change to 26,400. 27,000 is going to change to 29,700. Now consider applying the budget raise to departments which have lower budget than the average. So here what we are going to do, update department set budget to budget times 1.1, where the budget is less than 30,000. Raise to department, yeah, that we already have discussed that. We already have that. I think that was a duplicate. Let's get on with our life on the join operation. I said one of the most important operation in SQL is join. Join provides us a mean to reverse a normalization process. So if you have normalized it and you have a smaller table and you want to fuse them and you want to get back to the original table, how do you want to do the join? Now, as you know already, I have recorded the lecture on join alone, and I hope you can take a look at that and take a look at the example I put there so that you can understand what the join operation does. There are different types of joins that I discussed there. Now I'm going to discuss them not from a manual point of view, but rather from the code box point of view. Until now, we use Cartesian product to combine information from different tables. A join operation is used to combine rows from two or more tables based on a related column between them. There is some condition for sure. For example, if I wanted to list all lecturers and the courses each lecturer teach, we could use natural join. So lecturer ID, name, department name, course ID, semester year, from the lecturer table, natural join to the course table. So let's take a look. I have the example here, which is nice. So as you can see, I'm going to select lecturer ID, name, department name, course ID, semester, and year. And this is going to be the lecturer, and then it's going to be a natural join with the course. Remember, we had two different tables. It may be a long while for me, so this is page 83. If I wanted to take you back to my original table, I hope I can show you my table. Yes, this is department, this is a student, this is lecturer, this is course. I want you to join them, lecturer and course. Now we have here lecturer ID, we have course ID, we have name of the lecturer, we have office number, department name, we have credit, semester, year, and lecturer ID. Obviously, lecturer ID on the right-hand side of the course table corresponds to the lecturer ID on the lecturer table, and I'm merging them. So the way I'm going to merge them, I'm going to be conscious about this relationship that exists. This is kind of so this lecturer ID in this one is actually going to act as a foreign key, and this is going to be the foreign key is indeed a primary key in the lecturer ID. I'm trying to merge them. So keep your eyes on this. Let's go back to the page 83. I think it was 83, and I'm going to go back here, okay? So as you can see, I have lecturer ID, I have course ID, I have semester, both of them did. I have the year, and I have the name and the department name, okay? So that's going to be a natural join. We could do potentially on conditional basis. So I'm going to say lecturer ID should be the same as course lecturer ID. This condition has to be met in order for me to have the join. So basically, if you take a look at this, if I wanted to put them together, the lecturer ID on the left and the lecturer ID on the right must match. And if they don't match, I'm going to purge them. I'm going to delete them. You can take a look at the recording we had in the past where we discussed that that these are going to introduce conflicts, and you have to remove them. Simply putting them together doesn't make any sense because there is conflict. Data is not healthy at that time. There is shortcoming with natural join. We needed to list all the lecturers with information regarding the courses they had taught, but the lecturer which had not taught a course were not listed in the natural join. If there is a lecturer, Stephen at the chemistry department, go back to the page 27, I believe. You would see that they are not going to be listed because they haven't taught any courses. That join says there is a course, there is a lecture ID. Has there ever been this course taught by a lecturer in the lecturer table? That's what it was. But there is a lecturer who was just hired, Stephen, at the chemistry department and hasn't taught any course yet. And it didn't show up in the natural join. Keep in mind that as soon as someone is new, whether a new student and a new lecturer, the university tries to arrange organization meetings, to arrange fast track support for a student who is joining the university, for a faculty member, or even the staff who is joining the university, because they need to provide this support and get them up to their speed. Now, if a student has been hired and he has not been assigned an office number, has not been assigned a course to be teaching and so on, I need to know that. And as well, healthcare, maybe orientation meetings, what to do, what not to do, policies and all that. So I really need to know if a Stephen is there and everything else is empty. And if it is empty or null, I need to alert the team that we need to provide support for this individual as soon as possible, right? So natural join doesn't do it. So we need to actually consider different types of join. There would be some records that would be missing when performing join on relational tables in natural join operation. The outer join operation is performed similar to the examples we have seen so far, just that it will preserve the records that may be missing from the natural join results. Now, we have shown these in the past. You have the left table, you have the right table. When I say left join, I say keep this on the left table and bring everything that could potentially come from the right table and make it as a whole. So left table originally is only this much. Bring everything from the right table and attach it to my left table so that I know what is there as a whole picture. Similarly, right join, you're going to have the right table and bring whatever is on the left-hand side. Again, I encourage you to take a look at the recording I have. Inner join, so basically it means the common part. The common part obviously is not going to have null at all. There is no null here, because when you say common part, I want you to make sure that everything is on the left and the right table are available in complete pieces of information. Full join means I don't care. There is something in the table A, the left table, that is not properly represented and fully explored on table right table, or there is something on the right table and not fully explored in left table. I just want you to put them all together, even if it is null. So there may be people here that are going to have null on the attributes of the right table, and there are going to be people in the right table that are going to have null on the attributes of the left table. No, I'm fine, put them all together. So that's the full join. So let's take a look at the join. So I'm going to ask you to make sure that when you are going to join the lecturer table and the course table, the left outer, we have seen that picture in the recording available on this channel. The lecturer ID of the lecturer and the lecturer ID of the course must be the same. There has to be no conflict and it must be the same. So this is a left join. There are other examples you can consider. Consider the database of suppliers and products. So this is a supplier name and the city. This is product ID and the product name. And then this is the main entity, the main table. The supplier ID is coming from here. So this is going to be a foreign key here. Product ID is going to come here. That's going to be a foreign key here. and then price is going to be here. And this case, you could potentially put this together as your composite key if you wanted to. There are multiple suppliers, each with an ID name and city, and numerous products provided by the supplier, each with an ID and name. You have a supplier to create, so you're going to create the supplier table. You're going to create the product table, and you're going to create the supplier product table. So this is supplier, this is product, and this is the supplier product table. And the way we're going to do, so this is a supplier with some names on it. We have products with some names on it, and we have supplier product, and we can see the price is also listed, okay? Now, if I wanted to list all of the suppliers with the product that they provide, we could write like this: select supplier name, city, name, price, from supplier, natural join SP, natural join product. I'm going to do two natural join. I'm going to take this here, do a natural join, and then I'm going to bring this here and do a natural join. I'm joining A, B, C, left, middle, and right tables. And we spoke in the past that you can have as many tables as you like. You can have 10 tables if you wanted to, and still you could do the join. And pictorially, if you take a look at the Venn diagram, it's going to help you to see what we mean. Now, if you take a look at this, this is a supplier name, repeated, of course, the city, because supplier is actually selling different pens, notebooks, and so on, and the prices are different. And when I join them all together, it's going to be a comprehensive list. So this is going to be AA Corp, AA Corp, AA Corp, that's one. 2 means XY traders, 2 means XY traders, 2 means XY traders, 1 means AA Corp, and 3 means BB Company, BB Company. And then these are going to be the product list, okay? This product list, another typo mistake. I brought the GPA here. It's not supposed to be GPA. It was supposed to be price. My apology. List all product IDs and supplier names for products supplied by a supplier in London. So I'm going to do inner join, supplier SID and supplier product SID are supposed to be the same, where the supplier city is London. So I don't want you to give me New York. I don't want you to give me Boston or anything else. I just want you to give me London, okay? And then not in, we have already discussed what not in can potentially do for us, and not supplied by any supplier in London. For example, there is some trade issues, and they decided not to trade this particular supplier in London. So that's one thing you can keep in mind. We want to list all of the suppliers' information that provide black pens. So as you can see, from now on, the commands are really simple to follow. You do have the join, you do have the condition that we have that we could potentially utilize. Now, I don't want to discuss this for too long. The discussion is some advanced SQL features. I want to make this as brief as we can. And then hopefully we are going to close this long lecture series. For view, obviously, we want to allow, for example, there is a certain permission for the parent to see just the GPA of the students, the children. And this permission was granted by the child itself. Now, whoever the child is has granted the view to the parent, but not every record. So the parent would be able to see what the GPA, for example, is per term, but not all of the course grades. Maybe one course was failed, the other course did not. Some of them are A and some of them are C minus. The child did not approve to provide all of the little details, but the child approved only the view of GPA. This is why the view command is going to help. So consider a student which is viewing the list of lecturers from each department. Students do not need to see the budget amount of each department, right? This is another example. Why should the student know what the department budget is, right? A view is the result of a pre-established query on a database. A view can combine data from two or more tables using joins or just contain a subset of information from a table. This makes them suitable to abstract or hide some of the more complicated queries on a database. Here is an example. I have lecturer ID, name, and so on. I'm doing a left join from the course. And I'm going to do create view. I'm just trying to create a view. This is a command. By doing create a view, I'm going to actually allow a snapshot of this. So I'm going to go from the table where the condition is met. Here is an example. Create view, CS fall, course ID, year, lecturer ID, courses, semester fall, and department name is computer science. So that's the create view. That's the create view. It's just a snapshot. It's a thumbnail, I would say. Okay. Again, provide access to a subset of data, limit the exposure of the database design to the outer world, simplify the combination of information, provide aggregated data, GPA, average, reduce complexity. We don't want to see all of the nitsy-pitsy of the database. Views take very little space to store, only a limited number of attributes are going to be shown. There are two distinct statements. One of them is called procedure. The other one is called function. In the procedure, it's like a policy of the university. It says, let's do this, let's do this, let's do this. It's just a general understanding. You need to take the bus number 8. You need to go from A to B, change your bus from number 8 to number 10, and then you will get to your destination. It's a procedure. Whether you take that route or not is up to you. Whether there is going to be an outcome you are going to reach your destination or not is really up to you. In procedure statement, we do not produce output. We simply state the procedure. So procedure name, in, input, out, output, begin, SQL statement, create procedures, select your lecturers, in department, out result, begin, select everybody, every attribute into result from lecturer where department name is equal to the department. Run it out and see what happens. The next one is very important. The next one is actually a function file, a function statement. This is pretty much the same as the function file you have in C, C++, a function file you have in MATLAB, a function file that you have in any coding languages. In function file, not only we have a procedure, but we also return results. So there is going to be a return result. This is the biggest difference between function file and procedure. Procedure is just a policy. Function is not just a policy, it's a committee in motion. So a committee exists and the committee is going to take up the procedure and then going to produce the new dean of the college, select the new dean of the college and then announce it. So that's the function file. Function file is going to apply the procedure on that. Has many predefined functions like aggregate function, string function, all of those functions we have discussed in the past. A specific task and returns a result. Lets us create custom function. We need that because sometimes we don't want to repeat all of the conditions, the where, the selections of the table and so on. I simply want to do one thing. And as soon as I call upon the function, I want that specific train of thought, that specific procedure to be applied. For example, if you wanted to define a function to retrieve the student ID with a maximum GPA from a department, that department could be physics, that department could be computer science. I just need to pass on the department name and that's it. The function file is going to run the course. In function, it supports only input parameters in a stored procedure, input and output. Cannot call a stored procedure, can call functions. So a procedure can call function, that's very nice. Can be used in select queries, cannot be used in select queries. No transactions, can include transactions. Must return a result, no return value. Only select, can perform all database operation. So there are some points that you need to keep in mind. Again, that was not our intention to go through and give you examples. This is something that the follow-up courses are going to explain in more details. What did we do? We basically talked about SQL history, the commercial part of it, open source. You can see there are many of them available. We had data definition language, we had data manipulation language, we had join, we had different types of join, and we had views that were quite helpful for us. With that in mind, lecture series 4 is complete, and I will be trying to record a summary in a moment. Thank you.